So for this video, we're talking about introduction to alcohols. So alcohols are characterized by the presence of an OH group, which is generally in a bent shape similar to how water is formed. Alcohols are polar. They do contain an unsymmetrical distribution of charge between the oxygen and hydrogen atoms. The high electronegativity of the oxygen compared to carbon does lead to shortening and strengthening of the OH bond. The presence of OH groups allow for hydrogen bonding with other OH groups, hydrogen atoms, and other molecules. And since alcohols are able to hydrogen bond, their boiling points are higher than those of their parent molecules. And this is just an example up here, some isopropyl alcohol, otherwise known as rubbing alcohol. So naming of the alcohols. So according to the IUPAC nomenclature system, an alcohol is named by dropping the terminal E of the paired carbon chain. So, you're taking your alkanes, alkenes, alkynes, and then adding OL as the ending. If the location of the hydroxyl group must be specified, then a number is inserted either between the parent alkane name and the OL, as in propan-1-ol, or before the IUPAC name, so 1-propanol. If a higher priority group is present, such as a aldehyde, ketone, or carboxylic acid, then it's necessary to use the prefix hydroxy instead of the ending OL. Alcohols are classified as a primary, secondary, or tertiary based on upon the number of carbons connected to the carbon atom that bears the hydroxyl group. So you have your primary alcohols. In the primary, the 1-degree alcohol, the carbon which carries the OH group is only attached to one alkyl group. So you can see down here we have ethanol and propan-1-ol. So your OH is just attached to one carbon. In secondary alcohols, the carbon with the OH group is attached directly to two alkyl groups, which may be the same or different. So propan-2-enol, butan-2-ol, and pentane-3-ol. So you can see where they're all attached. And then with tertiary alcohols, and the carbon atom holding the OH group is attached directly to 3 alkyl groups, which may be any combination of the same or different groups. So 2-methyl-propanol, propan-2-ol. So here it's attached up here. 2-methyl-butan-2-ol. So again, up here. These are just some examples of alcohols. So you have over here, this one really goes over the primary, secondary, and tertiary. So you have your OH group attached there. These ones are going to be your primaries. This one's being attached to 2, so this is a secondary, and then this one's attached to 3, so that's a tertiary. Again here you can see just attached to 1, attached to 2, and attached to 3. These ones is kind of interesting. These are actually isomers, just because the OH is just in a different location, even though the rest of the molecule is pretty much the same. So with the OH being over here in a primary position, this is propyl alcohol or 1-propanol, and then with it being over here in a tertiary position, this is 2-propanol or isopropyl alcohol. Here we have butanol, so you can see this over here attached again at a primary position, and then you have your cyclopentanol, so again you have your OH attached at a primary position, or sorry, this would be a tertiary position, and it's also in a pentyl shape. Alright, here's some more examples down here at the bottom. 1-propanol, 2-propanol, and then 2-methyl-2-propanol. And then this is the fun alcohol that we all enjoy.